皆様、ようこそお越しくださいました。ドイツ・ダルムシュタットにある欧州宇宙機関のオペレーションセンターから生中継でお送りします。本日は ESA のアースケアミッションの打ち上げが行われます。アースケアのすべてを明らかにします。最後までお付き合いください。
Today, we are about to launch ESA's EarthCARE mission, a milestone project with a huge satellite and huge expectations. Hello, dear space community. Hello, friends of physics. And hello to everyone who cares about our Earth. A warm welcome from the European Space Agency's Operations Center here in Darmstadt, Germany. And a warm welcome also to all of our Japanese friends joining us. My name is Kara Monter, and I will be guiding you through our program tonight. While we broadcast live for the next hour, please use the obvious hashtag EarthCare to join the conversation and get involved. While it might be getting late, our program is definitely worth staying up for. We are joined today by some key scientists and engineers of the mission. We have a live link to the control room, and we will show the final sequence before launch, and of course the liftoff, with some stunning images from a bunch of onboard cameras. The countdown is now at T-minus 41 minutes, and will end at roughly 20 minutes past midnight. And for those of you who want to check in again with us later, we'll show you the first signal from space at around 1 o'clock Central European Time. That's 11 UTC. Now, with me is Thomas Ormston, who many of you know as a space expert and who has been working on this mission for 8 years. Let's begin with operation, Thomas.
Absolutely, and we're at one of the most exciting parts of the countdown right now, the roll call. This is where the flight director makes his last big check-in with all of the team, and I think we can listen in right now.
All positions in the briefing loop. This is EarthCARE, roll call. All positions shall report on this loop, responding to my request, quoting your call signs, followed by go or no go. Some go. EOCS go. Spacecon go. Data handling go. Platform go. Payload go. Timeline go. Project rep go. Project support go. Software coordinator go. Software support go. Flight dynamics go. OM go. S-track go. Scheduling go. Okay, this completes EarthCARE roll call.
All lights are shining bright and green. A very good start from ESA Ops, isn't it?
It is. We are go for launch at this time from here in Mission Control in Darmstadt. And across the ocean in Vandenberg, the launcher is looking good and is ready to go.
Now, Vandenberg is one of the launch sites on the west coast of the US. And our EarthCARE satellite will take off with a SpaceX Falcon 9 rocket tonight at about 20 minutes past midnight our time. Now, what's EarthCARE all about, Thomas?
So, EarthCARE is the 6th mission in ESA's Earth Explorer program and the largest at 17 meters long in total, carrying 4 completely new instruments that are all looking at one thing, well, actually 2 things, clouds and aerosols. They're locked in this complex dance with sunlight that drives our weather and our climate, but the actual mechanics of this process aren't properly understood.
Which is a catastrophe because it is one of the key components of global warming. In fact, it is the biggest unknown parameter of the climate debate.
Absolutely, and up until now, scientists have never had an instrument that can study all of these volatile and dynamic processes all in the atmosphere, all at the same point.
Up until tonight, because that's exactly why EarthCARE has 4 instruments on board. Let's go back to the main control room for a minute, Thomas, and see what they're doing, as we are now at about T-minus 38 minutes of the countdown.
Absolutely, and this is the main control room, ESA's Mission Control here in Darmstadt, Germany. Quite quiet at the moment. I think they might be taking a couple of minutes to catch their breath before the launch. We actually launched our first satellite from here back in 1968.
Oh my God, we weren't even born yet.
No, we weren't. But now we fly 27 spacecraft around the Earth and across the solar system, linked in together via a network of ground stations that span the whole globe. It's also home here to ESA's Space Safety Program, which includes planetary defense against near-Earth objects, monitoring and avoiding space junk, and also monitoring and forecasting space weather.
Both are big issues for spaceflight these days, aren't they?
Absolutely. Even though EarthCARE hasn't even launched yet, our flight dynamics and collision avoidance experts have already screened and plotted a path through the space junk that's unfortunately waiting for us when we arrive in orbit.
There's so much that needs to be taken care of. But right now, everything looks very relaxed and very quiet in the control room.
Well, it's our job to be relaxed, and sometimes we need to take a breather outside of the control room to do that. But actually, right now, there's not much that we can do from here in Darmstadt. The satellite is safely wrapped up inside the rocket's fairing. We're getting health data via an umbilical cable, so all the team can do now is monitor the status, and just like us, wait as the clock ticks down towards liftoff.
Real operations start with the first signal from space, and that's why we can now talk to Juan Pinheiro, the flight director of the day shift. Juan, you have just handed over to the night shift a few hours ago. How did you prepare for this?
Well, okay, the preparation for this, as you can imagine, was done during many years. So basically, everything that is used tonight was developed and tested a long time ago. Maybe this finished like 1 year ago. And then the last year, we have done what is called operational validation to see that all this big machinery can work together to do what it should do. And then finally, in the last months, we have the feared simulation campaign where a trainer officer basically injects all sorts of problems he can imagine, and he can imagine a lot, in every system, in the teams, everything you can imagine, and see how the team reacts to this, how the system reacts to make us robust. So honestly, I think one can say that the teams are, and the systems are as well prepared as they could be. And now we just need to wait for it.
Fantastic. That is great to hear. Thank you very much, Juan.
Thanks to you.
And Juan will take over tomorrow early morning.
But just like us, he can't go to bed yet.
Indeed, we all want to see the launch of EarthCARE, just like thousands of scientists do worldwide. And here are a few reasons why.
Clouds, aerosols, and radiation. That's what we're talking about today. The haze, the fog, and the clouds filter the sunlight. Some's reflected back up into space, but some passes through, trapping heat within and beneath the clouds. It's a hugely complex process that makes it really difficult to calculate what we call the radiation budget, or the balance between how much energy escapes our planet into space and how much is trapped forever here driving climate change.
And not only that, clouds are in a process of eternal change. Within minutes, even seconds, everything can look different.
Absolutely. And not only do they permanently move, form, and dissolve, there's a lot of unexplored processes at work, like how aerosol particles in the atmosphere are the seeds for icy cloud formation. The uncertainties in the behavior and the impact of clouds and aerosols translate into a huge variety of possible future scenarios for our climate. It's just a giant error factor with so many variables.
I mean, scientists say clouds cause up to 30% uncertainty in the climate debate.
Absolutely. Over the years, the IPCC reports have become so precise that this really stands out like a gap in the numbers. It's just simply missing.
But that's why EarthCARE is launched at such a perfect time right now.
Absolutely. Our knowledge of Earth's changing climate will be considerably less vague if we can nail down these figures about clouds and aerosols.
And we will. EarthCARE will deliver this data, that's for sure, and we'll now tell you why and how. With me now is Hélène Schipfer, Professor of Atmospheric Physics. Hélène, you investigate the Arctic ice, which is a key marker for climate change. What's the role of clouds and aerosols in the polar sea?
Okay, well, Arctic ice is melting fast, and we all know that. And this is under the influence of climate warming. And we need to understand how clouds, aerosols, and precipitation influence the speed of this melting. For example, precipitation being snow or rain makes a difference for ice melt. And the presence of clouds and aerosols, which reflect solar radiation and trapped infrared emission from the surface. They modulate the surface temperature, and this triggers the melt or delay the melt of ice in Arctic. The problem today is that we are not able to observe this component during daytime, which is the melt season from early spring to late fall in Arctic. And so we work with assumptions, and we do not have any ideas of this aerosols, cloud, and precipitation there. So EarthCARE will be able to observe and provide new data which are solid about this component in Arctic. And this is thanks to the LiDAR with HSL capability and the radar with Doppler capability. As passive sensors cannot do that, so that's critical for our science.
Fantastic. So this will make a huge difference in understanding the key components of climate change. Thank you very much, Elaine.
Thank you.
The EarthCARE project started 20 years ago. Even by spacecraft standards, that's a long time. It's been a journey with a lot of ups and downs along the way, whether it was external factors like COVID or the technical challenges posed by such a complex mission. Hundreds of obstacles had to be overcome, but everyone wanted to succeed. There's an even unexpected side effect, which was that we've been able to learn from other missions like Aeolus, making EarthCARE even better and even stronger. There has been a lot of work on this project by a lot of great people, and we really particularly want to highlight one of them tonight. The former EarthCARE mission scientist, Tobias Wehr, who sadly passed away unexpectedly a year ago. Tobias spent 21 years working on the mission as the driving force behind the science that it will soon produce. He gave confidence to the science community that the long wait would be worth it. Without his dedication, we wouldn't have come very far, and certainly not to where we are today. Tobias spent most of his professional career working for EarthCARE, and our thoughts are with his family as we all miss him on the day that all of that work finally comes to fruition.
I am now joined by two gentlemen who have extensive experience working in the space sector, Jerzy Lewanczyk from ESA and Terada Koji from JAXA. Jerzy, you were ESA's interface to Japan. Did you enjoy commuting between the two cultures?
Yes, it was an interesting experience. Coming to the agency with 20 plus countries at the time, I thought another one, go to Japan, no problem. However, I did learn differently. Even though I was always feeling at home and everything was more or less familiar, there is an expression in Thailand, it's same, but different. One comes very much to appreciate very quickly the discipline and the situational awareness that the Japanese have. And this became clearly evident in March 2011 when they had the big earthquake. And we were there, and the next day we were asking ourselves, what about the CPR? Luckily, everything went well. And we learned very much then about the total commitment of JAXA to the mission.
Fantastic. Thank you so much. Terada-san, you have spent so much time on the EarthCARE mission that you learned German in the meantime. Do you remember why the mission has been called EarthCARE?
So, guten Abend, meine Damen und Herren. Freue ich mich sehr, am EarthCARE Launch Event teilnehmen zu können. そう、私は25年、四半世紀にわたってですね、アースケアのさまざまな生まれに、関わりました。1999年、グラナダで、アースエクスプローラーの選考会議に参加して、日本と ESA の共同ミッションのプロジェクトを提案しました。その後、このミッションについて、この名前について、当時のカウンターパートであるペドロ・バプシスタ氏からアースケアという名前はどうかという提案を受けまして、これは素晴らしいという名前を素晴らしいと答えました。それから25年経って、アースケアは完成して私の目の前に現れました。素晴らしくかっこよく凛々しい姿を見て名前を付けたいと言って白龍バイサードラフェっていう名前を提案しました。日本は2024年、辰年です。白龍は世界中に幸せをもたらしてくれると思います。So, alles Gute zum Start von 白龍。Vielen Dank.
Thank you very much, Terada-san and Jersey.
And it was indeed Terada-san's idea to name EarthCARE the White Dragon, in Japanese Hakuryu, that brings happiness into the world, just as we expect the EarthCARE mission will do for our planet. There are in fact two separate processing and data distribution chains, one in Europe and one in Japan, to best serve scientists across the planet. And the mission will start with two validation campaigns, also one from Europe and another from Japan.
EarthCARE has very much profited between the cooperation between ESA and JAXA, between Europe and Japan. Takaguchi Futoshi is with me, the Vice President of JAXA. Takiguchi-san, why is it so important to cooperate on these large projects?
はい、気候変動は地球共通の課題です。その解決には国、地域、世界が協力する必要があります。特に今は国家や地域の分断が深刻な時代です。だからこそ日本とヨーロッパが協力したアースケアは異なる地域が共に同じ目標に向かっていける希望となり得ると信じています。Thank you.
I couldn't agree more. Shaping a future is up to us. Thank you very much, Takaguchi-san. And now, let's go over to Dominique Giron from ESA. Dominique, what have you taken away as a benefit from this cooperation between ESA and JAXA?
So the first obvious one is to get the best technologies from Europe and Japan to do this extremely challenging mission. And we could not have done it by joining our forces to get it together. But I think what I will recall the most on this cooperation is the resilience and reliability as a partner. As we have know from the previous speaker, it was a long development. And from time to time, it was even so critical that I wonder if my partner will continue to follow me in this mission. And I could have understood that they say, okay, guys, it's just too much, we have to stop. But they never did that. And it's the other way around, in fact. They support us when we were in a crisis, and when it was their turn to have some problems, we support them. And that's what I keep in mind for this cooperation.
Fantastic. That is so nice to hear. Thank you, Dominique.
The industry contract to realise EarthCARE was signed back in 2008 with prime contractor Airbus Germany. Here we see Angela Merkel and Volker Liebig kicking off what would become a mammoth project, starting with the spacecraft platform in Airbus UK, while in France and Italy, Airbus and Leonardo worked together to build the giant LiDAR instrument, while across the globe in Japan, JAXA led development of the CPR Doppler radar. Back in the UK, Thales Alenia Space UK and Surrey Satellite Technology built the two remaining instruments, the broadband radiometer and the multispectral imager. Overall, 75 industry partners from Europe, Japan and Canada have contributed to make EarthCARE happen.
You won't find an ESA member state that isn't involved in this mission. And together with the Japanese partners, all the bits and pieces came together and have finally been assembled at Airbus in Friedrichshafen. A large white satellite with a large solar panel. And now we are joined by Albert Zaklawa from Airbus, the prime contractor. Albert, the satellite has a new UV laser and needs to fly in a lower orbit than usual, and here it faces more atmospheric friction. Is that a problem for the mission?
Well, we would not call it a problem, we call it a challenge for engineers, and engineers love to be challenged. So our solution on this is that we made a very slim design, a very compact one. I would call it even a compact car compared to a compact car. 4 very important passengers on board, going with very low fuel consumption. And the trick is that we do a very low cross-section, and we keep the solar ray in the shadow of the body. And so we can fly this mission on this orbit.
Fantastic. Well, it's impressive engineering indeed. Let's now take a look back to our launcher as it stands and is ready to go on its launch pad. Thank you, Albert.
And everything is looking good at our launch site in Vandenberg with less than half an hour of the countdown to go. An ESA team is, of course, out there in California, and one of them sent us a message from the launch pad earlier today. Let's hear from Dirk Barnards, the EarthCARE project manager.
Good evening, everyone. I'm super excited here to go in a few minutes to the Launch Control Center to launch this incredible mission, EarthCARE. We're at this point with the satellite fully ready for launch, with the rocket fully ready for launch. And all this thanks to the very hard work of teams here in Vandenberg over the last few weeks and months, but also in Europe, in ESOC, in Japan, all over the world. Not only over the last few months, but over many, many years. And I know many of you are actually in the audience, and I cannot thank you all enough for the dedication and the very hard work that you did to bring this incredible mission to the point where we are now.
And here in ESA Mission Control is where EarthCARE will be operated from for its entire lifetime, 24/7, around the clock. And I'm happy to report, as you can see there, that the board is green, and at this time here in Mission Control Darmstadt, we are go for launch.
EarthCARE carries 4 state-of-the-art instruments. Its multispectral imager will provide an overview in multiple wavelengths to set the scene. The cloud profiling radar will detect vertical motion within clouds, providing details on their internal dynamics. Its atmospheric LiDAR will detect the top of clouds and provide profiles of the atmosphere with information on aerosols. And its broadband radiometer will measure the reflected sunlight and heat radiated from Earth. Together, these instruments form a powerful suite of tools that will provide unprecedented observations of Earth's atmosphere.
With me now is Kotske Wallace. Kotske, you were originally a principal engineer and now the optical payload manager working on EarthCARE. Here we see you amongst the early team. What has been your personal highlight over the years?
I've really enjoyed working on the technology developments for EarthCARE. We have some real cutting-edge technologies that we've managed to put onto one platform. It's been quite a challenge, as well as the Japanese radar. We have 3 optical instruments, and each one has come across difficulties, right down to the smallest instrument, which is the broadband radiometer. So the radiometer operates with 3 telescopes, and they're really rather simple telescopes. They're just single mirror telescopes, each pointing to a different viewpoint on the Earth. But they use a detector which makes an image by measuring the difference between the scene and a constant temperature target. And how do we do that? We have a drum which spins around those telescopes, and it has some holes cut in it, which is the view to the Earth. So that chops the signals onto the detectors so that they can make this measurement. But that means that that drum has to spin for the entire mission for several hundred millions of revolutions at very high stability, and it has to do that with a dry lubrication technique. So really it's quite amazing and quite challenging for such a small instrument compared to the other instruments on the other satellite. And we have 4 instruments operating together, and that's what makes the real difference for our mission, the synergy.
It's so incredible to hear. And what is the meaning of EarthCARE for your personal career?
For me, it's the first time that I've managed to get to launching a satellite, because normally I move on to another mission after the development. So this is the first mission where I'm working on the launch phase as well.
Well, you definitely deserve to see an excellent launch. Thank you very much, Kotske. And now the last 20 minutes of a 20-year project have begun. Let's take a closer look at these instruments. First up is the European LiDAR.
The atmospheric LiDAR is an advanced light detection and ranging system designed to measure the vertical profile of aerosols and clouds in Earth's atmosphere. By emitting light pulses and analyzing the reflected signals, EarthCARE's LiDAR can precisely provide the distribution and properties of aerosols and clouds. This includes their altitude, thickness, and detailed optical properties in aerosol type. This information is crucial for improving climate models and understanding the role of aerosols and clouds in Earth's energy balance.
Georgios Teramis is ESA's principal athlete engineer. Georgios, you know every screw of this instrument by name. Is there still something that impresses you about it?
Well, 1,532 screws and bolts on the satellite. But that's not the important number. There's one number which is far more critical for us, and that's 7.1 billion shots, 7.1 billion pulses. This is the number we need to reach in the UV region during the 4.5 years of mission. It was quite challenging to get there, and we will get there. These pulses are also very narrow. They're about 25 nanometers each. So if we look at how much light we actually emit, it's only for 177 seconds. So through the entire 4.5 years of operations, we will have only 177 seconds of light coming out of this instrument. How do we achieve the science then with this short period of light? Well, Ulla already mentioned that it's a unique instrument which is having the technology called HSRL, High Spectral Resolution Etalon, which is allowing us to separate molecules from aerosols. At the same time, we have something else which was never combined before, and this is a depolarization channel. Mixing these two technologies allows us to discriminate excellently between anthropogenic, man-made aerosols and non-anthropogenic, natural aerosols. So every scene that we're looking underneath a satellite can immediately be separated if it's industrial pollution or if it is biomass burning, if it is Sahara dust events, as already mentioned, or something else like volcanic ash. This is a unique capability, never seen before from space, and that's why it's such an exciting instrument.
It's very impressive indeed. Thank you very much, Georgios. And wait a minute, your son Dimitris is here with us today as well. Thank you for coming, Dimi. So, do you like what your dad is doing?
Hi. Hi. My teacher told us last week that scientists I
think scientists are very curious, right?
Yes. Scientists are very curious.
Yes.
You're doing great. So, do you also want to do something revolving around science like your dad?
Yes, because I find science very interesting, and I also like building things.
Oh, perfect. Then that's a good prerequisite. ESA's talent scouts, look out. So thank you so much for being with us, Georgios and Dimitris.
Thank you.
Thank you.
And let's come back now to the satellite and the next marvel of engineering on board, the radar instrument CPR. It's the first Doppler radar ever flown in space, and it was developed and built in Japan. Let's see what this instrument is all about.
The cloud profiling radar provided by JAXA enables EarthCARE to observe the internal structure of clouds. It operates in the millimeter wavelength range, penetrating through clouds and light precipitation. This provides detailed insights into their vertical structure and velocity, particle size distribution, and water content. This radar is essential for studying cloud processes, such as the formation and dissipation of clouds. It also contributes valuable data for improving weather and climate models.
With me now is Kawamura Seiji from the National Institute of Information and Communications. And no, don't worry, we aren't going to start a circus right now. Kawamura-san, the CPR radar is very prominent with its 2.5-meter dish on top. That's about roughly the size of this circle we have here, and the CPR radar we see up there. How did you build this?
はい、この CPR のアンテナ、軽くて丈夫である必要があるんですね。そのために CFRP という素材で作っています。で、このアンテナの表面にはレーダーの電波を反射するためにアルミニウムを蒸着しているんですけれども、当時、20年以上前ですね、CPR がまだEarthCAREに正式に採用される前ですけれども、このような大きなアンテナ 2.5 メートルに対して一度に蒸着するアルミニウムを蒸着するような技術がなかったんです。で我々これを、分割したアンテナで作ろうというふうに考えました。なので我々はこのアンテナのちっちゃいモデルで80センチの直径の、スケールモデルを作りまして、一面のアンテナと分割したアンテナとを使って、それで、分割したアンテナがちゃんと動くかというそういう評価をしていたんです。でところが、CPR が正式に採用されることが決まりまして、いざ作るという段階になった時にはこの大きなアンテナに一度に蒸着することができるようになっていました。ということで、我々のその、試作した、小さいアンテナというのは CPR に使われることはなかったんです。ただ、このちっちゃいアンテナが無駄になったかというと決してそうではなくて、我々は打ち上がった後CPR の検証とか構成をやるんですけれども、この、検証用の、地上設置のレーダー、ダブルタイのレーダーを我々作っているんですが、そのアンテナとしてその小さいアンテナは今使われているところです。
And how lucky we are that technology changed in due time to make this instrument happen. Thank you very much, Kawamura-san.
Thank you very much.
ESA Uyo. That is Japanese for controlling the satellite, and that's what the team down in the main control room is preparing to do right now. I've been told just a minute ago that our network of ground stations all around the world are standing by, starting with Hattebestuk in South Africa, then Kiruna and Svalbard high in the Arctic Circle, right at the top of Europe, continuing round to Alaska and then even Antarctica. We are ready to hear EarthCARE. We need them to stay in touch with EarthCARE as it flies from pole to pole in an orbit lasting 5,555 seconds, or about 1.5 hours in more normal numbers. And as the globe rotates beneath the satellite, we scan the planet every 25 days, but touching base every 90 minutes with our Nordic ground stations to download that precious data.
Walter Pelzer is with me now, hopefully. He's coming on stage. He is the Director General of the German Space Agency in the DLR. Walter, the control center is in Germany. EarthCARE is designed and integrated in Germany. Major science institutes are involved, and the DLR flies a validation aircraft and hosts a number of data networks. How does Earth observation rank in the German space agenda?
Well, I think, hello again, first of all, and I think we had this similar question already. Yes, a lot of the footprint of Germany in Earth observation is pretty high. The German ranking, or German ranks Earth observation on top of this list, whether it's in money-wise, whether it's staff-wise, and also in our space agency. So from this point of view, Earth observation is core when it comes to tackle the great challenges, climate change, other grand challenges we are facing on Earth. And I mentioned already earlier today that Germany is doing space to make life on Earth better. So from this point of view, it's #1 ranked in our space strategy. And so from this point of view, EarthCARE and this mission is #1 when it comes and when it comes to close to our heart.
Fantastic. Thank you very much, Walter. Keep up the pace. The world surely needs it.
Let's cross the finger for the mission.
Now, all ESA projects aim at one goal, serving the people on our planet. But is this recognized? And I want to ask the science communicator, Dr. Fission, about this. He runs the second largest Spanish science channel with an incredible 9 million followers. Doc, do people know what ESA is doing to take care of our climate?
Yes, absolutely. I have a feeling that people think that we are not doing enough for science and taking care of the planet. Instead, the ESA have the largest float of satellites taking care of our planet. So it's my mission as a science communicator to try to tell anyone that we are doing our best effort for the planet. Science, physics, engineers, all working together to have a better planet for our children and generations to come.
Fantastic. Thank you so much, Doc, for being with us 15 minutes before this EarthCARE launch. Now, before you leave, I do want to ask, since I have an influencer here, can I take a selfie with you?
Yes, of course.
Perfect. 1, 2, 3. Perfect. Thank you so much.
Thank you so much. Bye-bye.
In the last few weeks on its journey to launch. Starting in a clean room on the shores of Lake Constance, it was packed into a special container and transported by truck to Munich Airport, where the giant Antonov cargo aircraft was waiting to whisk it across the ocean. Everything was perfectly planned and measured, so the satellite and all of its support equipment fit precisely into the hold of the Antonov. It's a high-stakes job, and you can definitely see the relief and happiness on the face of EarthCARE payload manager Kotska Wallace. From there, it was a long flight across the Atlantic, ultimately touching down at Vandenberg Space Force Base in California after a brief stop for satellite customs clearance. All this time, the satellite had been safely enclosed in a special container that maintained temperature, pressure, and cleanliness for the whole journey, constantly under the watchful eye of ESA and the industry team. After arriving in Vandenberg, the container was carefully unloaded and brought by truck to the Astrotech facilities, where it could be unboxed and everything checked and rechecked. Thankfully, it was in perfect health, and we could go ahead and prepare everything for launch, including filling the tanks with 310 kilograms of hydrazine propellant. Finally, on the 15th of May, everything was ready, and the spacecraft could be mounted to its adapter, ready for a last dress rehearsal between the launch site and ESA's mission control in Darmstadt. With everything go for launch, just 5 days ago, the satellite was encapsulated inside the fairing, and just 2 days ago, rolled out to the launch pad, where we can see it now, waiting for the last leg of its journey in less than 15 minutes.
Before we go live to Vandenberg, let's have a message from Simone Tekeli, ESA's Director of Earth Observation, which he has sent us from the launch site.
To the ESA event from Vandenberg. We are here at the launch site. The project teams are ready, from Airbus, from ESA, with JAXA. The launcher is ready, the metal looks good, so really looking forward the launch of the 6.
And now, with less than 10 minutes to go, the satellite will now be switched to its internal power. That means that from this point on, it's on its own. It's going to be sipping power from its batteries until it unfolds its big solar panel once it gets to orbit.
Space friends and enthusiasts, thank you for being with us for the last 40 minutes.
By now, you should be experts in atmospheric physics, or at least understand enough about them to know why our mission today makes a difference to climate change.
It is now time to leave Darmstadt and go over to California, where our colleagues from SpaceX will take over for the launch.
We'll be right back with you straight after separation of the spacecraft.
So stay tuned and keep your fingers crossed for a successful liftoff and flight.
And the 340th overall Falcon 9 mission to date. My name is Zachary Lupin, and I'm an avionics reliability engineer here at SpaceX, and I'm joining you from our headquarters in Hawthorne, California. Welcome to our live launch coverage of the EarthCARE mission, a European Space Agency Earth Explorer mission developed as a joint project between ESA and the Japan Aerospace Exploration Agency, or JAXA. Now, the CARE in EarthCARE is an acronym that stands for Cloud Aerosol and Radiation Explorer. Once in space, EarthCARE will collect data to answer questions about Earth's radiation balance, which is a key factor in regulating Earth's climate. It will also measure vertical profiles of cloud particles and aerosols and their fall speed, or the speed at which the particles and aerosols fall through the air. This data will be used for climate research and will improve the accuracy of climate models and support weather predictions. We'll have more to share about today's payload later on in the webcast. Currently, both the vehicle and range are green, and we are on track for an on-time launch at 3:20 p.m. Pacific Time. For now, let's meet the vehicle and learn a little bit more about the most flown U.S. launch vehicle ever, our Falcon 9 rocket. Falcon 9 is a two-stage rocket developed and manufactured by SpaceX, known for its safe, reliable, and cost-effective access to space. It is also the first and currently the only orbital-class rocket capable of reflight. Starting at the top of the vehicle is the payload fairing, a protective shell that encases the payload being sent to space. That fairing will separate and jettison away from the vehicle, exposing the payload once Falcon 9 reaches space. Today's payload, currently encapsulated in those payload fairings, is ESA's EarthCARE.
Spacecraft is on internal power.
is ESA's EarthCARE satellite. Equipped with 4 primary instruments, EarthCARE will make a range of measurements that together will shed new light on the role that clouds and aerosols play in regulating Earth's temperature. The mission's data will be used for climate research and will improve the accuracy of climate models as well as support higher fidelity numerical weather prediction. Continuing down the vehicle, we have the second stage. Now, the second stage is powered by a single Merlin vacuum engine, or MVAC, which is optimized to perform in the vacuum of space. After stage separation, the MVAC will ignite and carry the payload to its final orbit. The Falcon 9's first and second stages are connected via the black inner stage, which houses the MVAC engine and the system that decouples the 2 stages during stage separation. And below that is the Falcon 9 first stage, which is powered by 9 Merlin engines. These 9 Merlin engines provide the initial thrust to lift Falcon 9 off of the ground through the lower, thicker part of the atmosphere. And there are 8 engines arranged around one center engine, which are held in place by a structure called the octaweb, a shape designed to maximize efficiency. Now, each of these Merlin 1D engines delivers about 190,000 pounds of thrust at sea level, which gives Falcon 9 a combined 1.7 million pounds of thrust. After stage separation, Stage 1 will return to Earth for recovery and reuse on a future mission using a combination of the Merlin sea-level engines and the 4 titanium grid fins located near the top of the booster, which will guide it during its re-entry and landing. The Falcon 9 first stage is also equipped with 4 landing legs that will deploy just before landing to allow for vertical touchdown on a drone ship or a landing pad. And today we'll be attempting to land this booster on Landing Zone 4 at Vandenberg Space Force Base in California. Now, weather and systems continue to look green for today's launch, and let's learn a bit more about today's EarthCARE payload on the pad.
We are facing a climate emergency. Understanding our planet is more critical than ever before. Our Earth is a complex system. To protect it, we need to fill in the missing piece of the climate puzzle. How do clouds and aerosols affect Earth's energy balance? While we know that they play extremely important roles in regulating our atmosphere's temperature, we don't know how their behavior will change as our climate warms. This is where EarthCARE comes in. ESA's Earth, Cloud, Aerosol and Radiation Explorer will shed new light on how clouds and aerosols affect our climate. With its suite of 4 cutting-edge instruments, EarthCARE represents a groundbreaking advancement in satellite technology. It promises to deliver unprecedented data, unraveling the complexities of clouds and aerosols. With this, we can refine our atmospheric models and climate forecasts, giving us the tools to tackle the challenges of a changing climate with greater accuracy and precision.
Tonight's launch is a reminder that space is not only about exploring distant galaxies and planets. It is about understanding our beautiful but fragile Earth so we can protect it and improve life on our home planet. EarthCARE is a groundbreaking mission developed by the European Space Agency in collaboration with JAXA, the Japanese Space Agency. It is thanks to this collaboration that we have been able to build such a sophisticated satellite. I should like to personally thank all the teams involved who designed and built the satellite and got it where we are today. They have shown a major commitment of time, talent and tenacity. I appreciate your dedication and share your excitement tonight.
I'd like to personally thank all the teams involved who designed and built the satellite, and to get it what we're here today, EarthCARE comes at a time perfect for climate science and climate communities worldwide. Let us seize this opportunity to deepen and expand our knowledge and to chart a course towards a more sustainable future for all of us. Go EarthCARE!
As you just saw, there's some really exciting science set to happen on this mission. But first, we need to get it to space. Now, in order to get the rocket and payload into any orbit, the rocket has to not only go up really fast, but it also has to go sideways. And as the rocket descends, we'll tilt the engines, and that'll turn the rocket horizontally into what's known as a gravity turn. To help demonstrate this concept, we'll use an analogy popularly attributed to Sir Isaac Newton, who was the first person to formulate a comprehensive theory of gravity in his 1687 Law of Universal Gravitation. Newton asked to imagine firing a cannon from a really high mountain. The cannonball will arc, and then gravity will pull it down to Earth. Now, as you increase the power of the cannon, that cannonball will arc and land farther and farther away. Eventually, if you could continue to increase the power, the cannonball will end up in free fall around the Earth. Essentially, gravity is pulling down on the cannonball, but because of its speed and the curvature of the Earth, it never hits the ground. And this arc that constantly misses the Earth is called an orbit. Modern rockets like the Falcon 9 operate on the same basic principles of gravity and orbital mechanics that Newton described, but with modern technology. And Falcon 9 provides enough power and horizontal velocity to place its payload in orbit above the Earth.
Tanks are pressing for strongback retract.
Good call out there. You'll be able to see this today by watching the orientation of the Falcon 9 after liftoff. The rocket will go straight up until about the T+10 second mark, at which point we'll begin a shift towards a horizontal orientation from gimbaling the engines. So be sure to look for that after liftoff. Coming up shortly, the Transporter Erector, or TE, will retract away from Falcon. The TE is the large truss structure you see there next to the rocket. First, we'll see the clamp arms open around
retract has started.
Around the second stage, and then the TE will pull away from the rocket by roughly 77 degrees. Now, that first stage is connected to a launch mount at the base of the TE, but the TE is hinged and will retract away from the vehicle in preparation for launch. You may hear the TE referred to as the strongback from the launch team, and it does a lot of heavy lifting in the lead up to launch. It's designed to transport, raise, and support Falcon 9 at the launch pad. The TE is also equipped with umbilicals or flexible lines that are used to route the vehicle's fluids, power, and telemetry from the ground systems to the rocket and payload until Falcon 9 switches to internal power and clears the pad. And as you can see on your screen there, the strongback is retracting away from the vehicle. At this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of rocket-grade kerosene fuel and liquid oxygen. Both the first stage and second stage should finish propellant loading about a minute apart from each other, with the first stage finishing up at around the T-3 minute mark, and the second stage finishing at the T-2 minute mark.
Stage 1 LOX load is complete.
And there's that call out that Stage 1 LOX loading has completed. As you may have noticed, there are white clouds forming around the vehicle. Those clouds are comprised of the chilled gas above the LOX tank that is vented overboard to maintain pressure in the tank as needed. And when that vented oxygen mixes with the warmer California air, it condenses into clouds. At the T-60 second mark, Falcon 9 will be in startup, and this means that the rocket's autonomous internal flight computers will have taken over the launch countdown, and then just inside of T-2 seconds, we'll light the M1D engines for liftoff. The EarthCARE payload continues to be healthy, and the Falcon 9 team is tracking no issues on the rocket. Weather is still looking green, and the range is ready to support our T0 of 3:20 p.m. Pacific time. And with that, we're proceeding into the last couple minutes of terminal count.
Stage 2 LOX load is complete.
And there's that call out that Stage 2 LOX loading is complete. Falcon 9 is now fully loaded with 1 million pounds of propellant and oxidizer.
Ground gas closeouts.
Good call out there. In about 20 seconds from now, we should hear a call out that Falcon 9 is in startup. And as a reminder, this is a call out that the rocket's autonomous internal flight computers have taken over the launch countdown.
Falcon 9 is in startup.
And there's that call out that Falcon 9 is in startup. Lastly, we're waiting for the launch director, or LD, to give the final go for today's launch.
LD is go for launch.
And with that call out that the LD is go for launch, we are set to launch ESA's EarthCARE payload.
T-minus 30 seconds. T-minus 15. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Go Falcon 9, go EarthCARE. Vehicle pitching coverage. Stage 1 chamber pressure normal.
At T plus 30 seconds and counting, Falcon 9 has successfully lifted off from Slick 4 East carrying the EarthCARE satellite. Now, after clearing the tower, we tilted or gimbaled the engines to initiate a roll maneuver, which you may notice in the Stage 1 camera view. This enables the vehicle's antennas.
Telemetry nominal.
This enables the vehicle's antennas to stay in the best position for communicating with the ground. In just a few moments from now, we'll be throttling down the engines in preparation for max Q, or maximum aerodynamic pressure.
Vehicle supersonic. Max Q.
And there's that call out for max Q. Now, as Falcon 9 accelerates through the thicker lower atmosphere, the air density decreases, and Falcon 9 passes max Q once the air density lowers faster than the increasing speed of the vehicle. So keep an eye on the Stage 1 telemetry on the bottom left-hand corner of your screen to watch for these speed changes through ascent.
And back chill.
Good call out there. And as a reminder, the rocket typically needs to go 17,500 miles per hour horizontally in order to avoid being pulled back down to Earth and get into orbit. Now we've got 6 events coming up happening in rapid succession. This will start with main engine cutoff, or MECO, where we shut down all 9 M1D engines on the first stage. Followed by that will be stage separation, where the first and second stages separate. Third will be the Stage 1 flip, a maneuver to turn the first stage around. Then we'll have the second engine start, or SES1, on the second stage. Fifth will be the first stage boost back burn, a controlled burn that reduces the forward velocity away from the launch pad. And lastly will be fairing separation, where the 2 fairing halves will jettison away from the second stage. And all of these events should happen in just a few moments from now.
MECO.
Stage separation confirmed.
And vac ignition.
Stage 1 boost back burn.
Fairing separation confirmed.
And there you heard and maybe even saw those 6 events that happened back to back, which again were MECO, stage separation, Stage 1 flip, second engine start 1, the first stage boost back burn, and fairing separation. We'll be attempting to retrieve those fairing halves, both flying for their first time today, once they fall back to Earth with our recovery vessel, Go Beyond. Coming up shortly, we should hear a call out for boost back shutdown on the Falcon 9 first stage.
Stage 1 boost back shutdown.
And there's that call out for Stage 1 boost back shutdown. We're currently T plus 3 minutes and 34 seconds into the mission. Our next major mission milestone will be...
Both vehicles are following nominal trajectories.
Good call out there. Our next major mission milestone will be the first stage's entry burn, which will take place just past the T plus 6 minute mark. Now, to start the entry burn, we will relight 3 of the M1D engines on the Falcon 9 first stage, which is similar to pumping the brakes to slow down the vehicle as it passes back into the Earth's atmosphere. The entry burn helps reduce the heat generated from the friction of the atmosphere and reduces the aerodynamic forces acting on Falcon, which helps maintain controlled flight and prepare for the landing burn. Now, during the entry burn, Falcon 9 is decelerating by firing its Merlin engines, but it's still moving really fast, and this causes the vehicle to fly through Merlin's exhaust gases, or plume, which deposits a layer of soot on the vehicle surface. And that soot comes from the carbon-based fuel that Falcon 9 uses, and with each flight, the soot builds up a little more on the outside of the vehicle. Some amazing views of the MVAC engine on our Falcon 9 second stage as it takes the EarthCARE payload to orbit. Reusability is key to lowering the cost of spaceflight, which enables more investments in critical scientific research. Now, the Falcon 9 first stage that is supporting today's mission is performing this entry burn for its 7th time, coming up shortly. Now, the Merlins on the first stage are optimized for sea level, and these achieve 190,000 pounds of thrust each during ascent and descent. At liftoff, Falcon 9's first stage has thrust greater than 5 747 airplanes at full power, and the MVAC engine on the second stage, with a much wider nozzle, is optimized to 220,500 pounds of thrust in vacuum. Now, as a reminder, the first stage supporting today's mission is flying for its 7th time, having previously supported NASA Crew 7, CRS-29, PACE, Transporter 10, and 2 Starlink missions. It's also worth mentioning that this is the 56th Falcon 9 launch of 2024 and the 18th launch of Falcon 9 this year from Vandenberg Space Force Base in California. Coming up in just a few moments, we should hear the call out for the entry burn on the Falcon 9 first stage.
Stage 1 entry burn startup.
And there's that confirmation of entry burn startup. This burn will last about 20 seconds and will slow the vehicle down in preparation for the landing burn.
Stage 1 entry burn shutdown.
And there's confirmation of Stage 1 entry burn shutdown. We're now waiting for Falcon 9 to land back at Landing Zone 4 at Vandenberg Space Force Base in California. And it just so happens that Landing Zone 4 is actually only about 440...
Both vehicles are on nominal trajectories.
Good call out.
Stage 1 FTS has saved.
Good callouts there. It just so happens that Landing Zone 4 is actually only about 440 meters away from Slick 4 East at Vandenberg.
Stage 1 transonic.
Good call out there that Stage 1 is transonic. We should hear a call out for landing burn startup on the Falcon 9 first stage in just a few moments.
Stage 1 landing burn. Stage 1 landing light deployed.
And there you have it. Falcon 9 has successfully...
Stage 1 landing confirmed.
Falcon 9 has successfully...
Stage 2 FTS is saved.
Stage 2 is in terminal guidance.
Good callouts there. Falcon 9 has successfully landed at Landing Zone 4 at Vandenberg. This was the 7th launch and landing for this first stage. And this landing marks SpaceX's 314th recovery of an orbital class rocket, including first stage landings for Falcon 9 and Falcon Heavy. Coming up next, we'll hear a call out for SECO 1, or Second Engine Cutoff 1, on the Falcon 9 second stage, currently on your screen.
MVAC shutdown.
And there's that call out for MVAC shutdown on the second stage. We're now waiting for confirmation of nominal orbital insertion.
Nominal orbit insertion.
And there's that call out. Now with that call out, we're just one major milestone left in our mission, which is payload deployment, coming up in about a minute and a half from now. Now, Earth Explorer missions like this one are state-of-the-art science and research missions that deliver data to fill gaps in Earth system science and demonstrate new space technologies. EarthCARE is the largest and most complex Earth Explorer satellite to date. The satellite carries 4 state-of-the-art scientific instruments that work together to provide a holistic view of the interplay between clouds, aerosols, and radiation, a cloud profiling radar, an atmospheric LiDAR, a multispectral imager, and a broadband radiometer. Together, these instruments will allow scientists to better understand the processes governing the physics and interaction of clouds and aerosols and their impact on Earth's temperature. We're expecting payload deployment of the EarthCARE satellite in just under 40 seconds from now. As a reminder, this is the 56th Falcon 9 launch of 2024 and the 18th launch of Falcon 9 this year from Vandenberg Space Force Base in California.
EarthCARE separation confirmed.
An amazing view there on your screen. Successful deployment of the EarthCARE payload. And with that confirmation, we'll be bringing today's webcast to a close. Today's mission marks SpaceX's 351st overall mission to date and 56th mission of this year. We want to thank the European Space Agency and JAXA for entrusting us with today's mission, and all of you for joining us this afternoon. If you're interested in following the EarthCARE mission further, tune into youtube.com/ESA for more. And if you're interested in more launch coverage, be sure to check out spacex.com/launches for the most up-to-date information. Thanks for tuning in, and we'll see you again soon.
Amazing pictures. I meant to talk now. I wasn't ready for this much emotion seeing our spacecraft, our EarthCARE flying free. But we're here back in mission control here in Darmstadt, Germany. And I want to tell you a little bit about what's going to happen over the next 40 minutes, because we have a little bit of time to wait before we hear from EarthCARE for the first time here at Mission Control. But the satellite's not going to be quiet. Very soon it will start going through a set of automatic steps to turn on its transmitter so it can talk to us, to get things like that big solar array ready so it can generate power, effectively to be ready for that first conversation which we hope to have with it very, very soon. The satellite itself is now going to fly down towards Antarctica, come up under the South Pole, and we will pick it up again, as I say, in around 40 minutes from now at our ground station in Hartbeespoort in South Africa.
Oh, amazing news, really incredible. Now, with me is Torsten Fehr from ESA. He is the EarthCARE mission scientist, and he looks very happy.
Kara, I'm very happy. I mean, this is an emotional roller coaster, and I guess that everybody in the room and also the viewers online, I mean, for us, this was just such an exciting moment, and to see this perfect launch and the deployment of the satellite, I mean, this is just, and I'm talking much too fast, but I'm so emotional. Seriously, to see this after so many years that we've been waiting, after hundreds, thousands of people have been working on the satellite for such a long time, with the scientists, of course, as a mission scientist, this is dear to my heart, supporting us and driving us through all of those years with our Japanese partners. This is just fantastic. I have to say, this is, I think, probably one of the greatest moments in my professional life ever. It's fantastic. I cannot be more happy at the moment. We still have some time to go. We're not there yet, but we've done a big leap forward.
Incredible work. I mean, this is fantastic news, and the excitement is infectious. Science is on a good trajectory. Thank you so much, Torsten.
Thank you, Karen.
Now, let us also look into how the public reacted during the EarthCARE launch. Jessica, you graduated with a degree in space engineering, and now you're a science communicator focusing on inspiring young people to learn more about science and technology. I mean, it's always so exciting to see such a launch, isn't it? I mean, especially for such an important mission. What is the feedback from your community like for missions like EarthCARE that focus on climate data and Earth observation?
The feedback's been absolutely amazing. I have quite a lot of young followers who are concerned about why we go to space, but also they're concerned about the future of sustainability because climate change is such a big topic. So I think missions like today's have been amazing. It's been covered just in the best way possible because it's set to inspire a new generation of scientists and engineers and also educate the public. And I'd like to quickly take the opportunity to say I have so much respect for everybody in this room. What you've achieved today has been phenomenal. And as an aerospace engineer myself, I really, really do think it's fantastic. And I'm so excited to see the future, what it holds.
Thank you so much, Jessica. The work you do is very important. Thank you.
Thank you.
So we'll be back in time to see the important moment of the first acquisition of signal in about 40 minutes' time. For now, we will close our live broadcast from ESA TV for a short break. For those of you who are feeling very tired now, thank you so much for watching, and stay tuned for the next steps and for ESA's future Earth observation missions. Follow ESA and JAXA's social media channels, but hopefully see all of you later for the first signal. In the meantime, please enjoy these views from the mission control room. And now,
1, 2.
Dear space friends and enthusiasts, I am Chiara Monter, and with me is Thomas Ormston, and we are back on screen for a quick live broadcast about the EarthCARE mission, the launch, and the EarthCARE is a European and Japanese cooperative mission on clouds and aerosols.
Indeed, and for about the last 50 minutes was when we saw the launch, and for about the last 40 minutes, the satellite has been flying free in orbit, waiting for us.
Now we expect to receive the first signal coming down from the ground station in South Africa, straight into ESA's main control room here in Darmstadt. Thomas, it's a very tense moment, isn't it?
Yeah, I think it's a tense moment in the room. here, but also where you can see now in the main control room, everyone will be watching their screens and getting ready for what's coming next. In fact, the most important screen in this room right now is the wiggly yellow line that we'll have a look at in a minute. At the moment, there's not much happening there. We expect that to change very soon because our ground station in Hertebestuk in South Africa is pointed to the horizon, waiting for EarthCARE to rise above it and start talking to us for the very, very first time. When that happens, we expect to see a spike on that graph. That will be the first sign that EarthCARE is there. It should actually already be talking. We just can't hear it yet. It turned on its transmitter automatically, so it's sending out a signal. We just need to wait for it to come up round Antarctica and up towards South Africa, where we can finally listen to what it says. Once that happens, there'll be a very frenetic pace going on in the main control room. There'll be a lot of activities happening all at once. I'll try and guide you through them as we do get there. And right now, I think we're going to take a close look at that signal and see if we see something coming from EarthCARE. This pass, we call a pass, is what we call when the spacecraft comes over the ground station, is something we call downlink only. That means the spacecraft's only talking to us. It's great because we'll learn a little bit about how it's doing, how it's feeling now that it's in space. But the problem is we won't be able to send anything to it. We have to wait another 20 minutes or so until the spacecraft's heading up into the Arctic Circle, where we'll pick it up again at our Kiruna and Svalbard stations, where we can finally actually have a proper conversation with the spacecraft. Now you can see, of course, on the faces, everyone is staring at those yellow lines. At the moment, everyone is poised to go, like a runner in the starting blocks. I've been in this room many times. I know what it's like to sit there and wait for this signal. So it's just patiently waiting and watching.
So there's nothing else anyone can do? They're all really watching for that line in the room?
Absolutely. That's what we're doing. The person at the back of the room will already be quite busy, and that's the ground operations manager. They will be looking and talking to that station in South Africa and making sure they're pointed in the right place to be able to pick up the signal. Of course, it's not every day they get a brand new spacecraft coming to orbit, so they'll be pointed there, poised, ready to receive the signal from the spacecraft when it comes. What the team's going to be doing, though, when we get that signal, is they'll be looking very closely at the data that's in that signal. We will just see a spike, but their screens there along the front row of the main control room will light up with all sorts of data about the spacecraft.
Maybe you can tell us a bit more about the data they will see, maybe some examples.
Absolutely. I mean, this data is not the science data that we've been talking about today, but health data. This health data is more about how the spacecraft's feeling, what the temperature's like. Oh, and it looks like we have a signal. We can see that little spike. And we will cross very shortly to the main control room, where the daytime flight director, Juan Pinheiro, is waiting to confirm that that is indeed the signal from EarthCARE. Juan, can you hear us?
So we can confirm from the main control room that we had acquisition of signal, we are getting telemetry in the systems, and we already see that the solar array is separated and the status of the satellite seems pretty normal at the moment.
That is absolutely fantastic news coming from the main control room. Not only do we have that signal, but we already know that the solar array is out. As a spacecraft operator, those are the two things I want to happen the most. If we can talk to it and we can generate power, we have a spacecraft and we can fly for many years to come and deliver all of that science. So I was saying what they're actually looking at, because we're all celebrating. We can all party now. Their work is just starting in the main control room. So they are seeing things like the temperatures on the spacecraft, what its computer's doing, how stable it is, how much power that big solar array is generating, all of the different things. And they'll be checking that against what we expect to happen. And there will be unexpected things. It happens on every space launch. So they will be learning how to fly the spacecraft, because everything is fine in theory when it's on the ground, and we have tested it a lot, but nothing compares to when a satellite's in space for the first time, experiencing being in the space environment. We have actually, though, prepared for this. We've prepared a lot for this situation. We've been doing simulations campaigns. It's been mentioned a couple of times. It's actually one of the most fun things we can do here, which is that we've been practicing this over and over and over.
And how do you practice this? Does someone make scenarios? And I think we can hear now from Juan Pinero again, before we talk more about simulations.
So just a very brief update. The team has already completed the basic checks that they had to do during this station pass, and all the checks have passed, so the satellite seems nominal at this stage.
Fantastic news.
More good news. And fantastic that those simulations paid off, because they did those checks at lightning speed to tell us that the spacecraft is healthy. Which is fantastic news. So yes, we practice actually underneath that room. There's a dark cave. Actually, no, it's our simulation studio where our simulations officers sit, and they pipe data up to us when we're working in that room while we're practicing doing these simulations.
Something like aliens are coming, or what kind of data?
Well, some of them are fancy technical difficulties and things like that, but sometimes it can be something as simple as them calling you up and saying, "You're sick, leave the console," because we have to be ready for anything. Someone can get sick and we still have to work. We also learn the basics of what it means to work together as a team. Things like blaming and shaming people has to be banished from that room. You have to be willing to say, if you make a mistake, to put your hand up and for no one to blame you, but to just work through it, because we're not in the business of stopping human error, we're in the business of managing it. People are going to make mistakes, but we learn how to overcome them, and we learn how to overcome an awful lot of other challenges in there, which is why, hopefully, real spaceflight is boring for us. That's what we would like. Now, of course, there will be challenges, and over the coming days and months, there's a lot that EarthCARE has to do. We'll be in this room here for another 2 or 3 days while we do the basics of what we call launch and early operations phase. This is the immediate arrival of the spacecraft in space, getting it ready in its new home. But there's a longer period of 6 months after this where we'll be doing commissioning, where all of those complicated science instruments that we've talked about so much today will be checked and tested, their data will be analyzed and calibrated to make sure that we can deliver the mission that we want for the scientists throughout this.
Perfect. Well, I think now it is time for us to talk to Björn Fromknecht. He is the future mission manager. Incredible news, right?
No, really, really beautiful. I mean, I'm speechless, actually. It's very beautiful emotions, very intense, and we have been waiting for that for a very long time. So, excellent, really excellent.
Fantastic. Now, not to burst the bubble a bit, but the tension is not fully over yet. There's still a lot of work to be done after this, before the real data comes in, right?
That's right. We have to calibrate the instruments, so we have to make them work properly, find the right settings to get the maximum performance out of them, to fulfill our scientific objectives. This will take roughly 6 months. Then we plan to release the first data to the user community. One major step is calibration and validation campaigns that are planned for this summer. There's also a big German contribution to that. Usually we mount instruments that are similar to the instruments of EarthCARE on planes, and then we fly underneath to get measurements that we can compare to the satellite measurements, and like that calibrate and validate our scientific products. And our Japanese colleagues, for example, have a mobile radar station that they can move along a river to help calibrate the CPR.
Fantastic. Thank you so much, Björn, for filling us in.
Thanks a lot.
I hear now that it is time to once again move from Darmstadt back to California. And we have some final words from the Director Generals of ESA and JAXA, as well as from ESA's Director for Earth Observation. So over to Vandenberg.
Okay. Hello, everyone, to ESOC. I mean, this is an amazing feeling we have. As you see, we are sitting in the bus now, actually on the way to the press conference in the other hotel. But I can say this was a huge relief. I'd like to say hello to all the people in ESOC. Thank you to all of you who have made this possible. There are member states, there's industry, decision makers, and of course to my friends and our partners in this mission, JAXA. I have next to me the president of JAXA, Hiroshi-san, and we are both just thrilled and excited, and really a quick hello from here, and well done everyone. This is and we look forward to the data to come. But I hand over to my colleague and Hiroshi-san.
Hello, everyone. It was really a beautiful launch, and I was deeply moved by to have witnessed the spectacular launch of EarthCARE together with ESA Director General Ashbacher, and also ESA Director of Earth Observation Program, Simonetta. And I would like to also extend my congratulations to everyone at ESA, SpaceX, Airbus, NICT, and NEC, and everyone who have dedicated their efforts to the development and successful launch of the EarthCARE satellite. And I also would like to appreciate many engineers, scientists, policymakers from various countries who have supported the EarthCARE program from its inception. And I think, according to the latest information, EarthCARE has safely embarked on its journey into space, and from now on, together with ESA, we would like to engage in the initial operation of EarthCARE and finally to the full-scale operation. And anyway, I hope that the EarthCARE data will contribute very much.
Please also my side.
Okay, I think we might have lost them. I'm happy to say that our connection to EarthCARE is a lot better than our connection to California right now.
Okay, we have a signal again.
We've got them back. We've got them back.
There we go.
Something just happened. Signal again. No. Signal again. Yeah, that's why everyone was applauding. Okay, I think.
I think that might be the last of them.
All right. I think we have lost them now, but...
Thank you very much for being with us with those wonderful words from the Directors General of ESA and JAXA. We will close our broadcast tonight.
Our dear viewers, thank you so much for watching and keeping your fingers crossed. Stay tuned on our social media channels and come back the next time ESA launches a scientific satellite into space. We close it here and wish you a good night and goodbye. Thank you.